So let's solve this problem. Find this integration. So integration on a region R of 4x plus 2 with respect to the area, where R is the region of the plane contained between the graphs y equals x squared and y equals 2x. Okay? So this is our xy plane, and here is the graph of y equals x squared, and here is the graph of y equals 2x. So the area between these two graphs is this region here that we have called region R. So the question is asking us to calculate the integral on region R of an equation which is 4x plus 2 dA. Or you could write dA, or you could write dx dy. So what does this mean? So this means that we are calculating the volume that is between the xy plane and the surface given by 4x plus 2. Okay, it would be very difficult to plot. Let me try. So if this is our xy plane, now I'm drawing it in 3D so that I can draw as the height the function f of xy, which is 4x plus 2. Okay, so how does 4x plus 2 look like? So this is a straight line with slope 4 and intercept 2. So it's a straight line like this, something like this. And this is in the x direction, but in the y direction it's constant. Yeah? It doesn't depend on y. So I could draw something like that. So it is this surface here. It's like the roof of a shed. Yeah, something like that. But now we are integrating this function on this region. So this region looks very strange. So this region looks, so we have a region here that looks something like this. Okay, so this is our region of integration. So what we are doing is we are kind of mapping how the function is on top of this region. Okay, so every point on this region maps into a point on the function. So we are getting this shape on the roof of the shed. Okay, and now we have to calculate the volume of this interesting object, which looks like an ellipse, which is taller on one side than on the other side. Okay, that will be the result of the function, because remember that this is simply the volume that is between the graph of 4x plus 2 and the xy plane, but only limited to this region R. So that's why we are only limited to this strange object here. Okay, so I hope that's clear what we are doing. So now of course we have two options. We first integrate along x, or we first integrate along y, and I have shown them here, and I have written what the limits are. So first of all, if we are first integrating along x, so when do we enter and when do we exit the region of integration? So we enter the region of integration in this line, y equals 2x, which we need to solve for x. So that's why we write x equals y divided by 2. Okay, so from y equals 2x, we arrive here. While the point where we exit the region of integration is this other curve, which was y equals x squared, which we solve for x, so x equals the positive square root of y. Okay, so those will be the limits for x between y over 2 and square root of y of the function, which is 4x plus 2 dx. This will be the inner integral. And the outer integral, what are the limits of the outer integral, which is with respect to y? So remember, we get the region and we project it into the y-axis. So we end up with this line here, which goes from y equals 0 to some point. Which point? The point where the two curves intercept. So that's a calculation that I should have done earlier. So when does the curve y equals 2x intercept with the curve y equals x squared? So we need to solve this simultaneous equation. So 2x equals x squared. Okay, so this means that 2 equals x. Okay, which means that y equals 2 squared, which is 4. So this point is the point 2, 4. Okay, which means that the upper limit of integration along y is y equals 4. So the integral goes from 0 to 4. Okay, and now we are ready to do this integration. Alternatively, we could also do the integration in the other direction. So we first integrate along y. So if we are first integrating along y, we draw a line in the y direction and we check when does this line enter the integration region and when does it exit. That will be the lower and the upper limit. So let's write it down. So we're integrating our function, which is 4x plus 2 with respect to y. So the lower limit is going to be this line here, which is y equals x squared. And the outer limit, the upper limit, will be this line here, which is y equals 2x. Okay, so that will be the inner integral, which we then integrate along x. And what are the limits in the x direction? So remember, we get this area, we project it into the remaining axis, which is the x-axis, so it goes between 0 and 2, because remember that this point we calculated, it's equal to the point 2, 4. So x goes between 0 and 2. These two integrals will give you the same answer. Okay, so we have to choose one. So either we do A or we do B. I'm not going to do both this time. I'm going to choose B because I think it will look easier. Why do I think so? Because I don't like the idea of having a square root of y, having to do square roots of y, and then the integral of square roots might be uglier than here. It looks nicer, right? We will have some polynomial, we will substitute x squared and 2x, so we will have a nice polynomial to integrate with respect to x. Okay, so I'm going to choose B. So the integral is equal to the integral between 0 and 2 of this inner integral. So what is the integral of 4x plus 2 with respect to y? So that's very easy. It's 4xy plus 2y, right? Or we could actually say 4x plus 2 times y. Let's write it like that. And we need to substitute y equals x squared and y equals 2x. Okay? And we still need to do the outer integral later. So if we substitute those, we get the integral between 0 and 2 of 8x plus 2 times 2x minus, no, I'm doing it wrong. So I have to substitute y equals 2x, so that remains us with 4x plus 2 times 2x, minus substitute y equals x squared. So 4x plus 2 times x squared. Okay, so all this is what we need to integrate now with respect to x. But of course, first we can simplify it. So if we simplify that polynomial, we arrive at 6x squared minus 4x cubed plus 4x, which we need to integrate with respect to x. Okay, so we do the integral. So the integral of this is relatively easy. It's 2x cubed minus x to the 4 plus 2x squared, evaluated between x equals 0 and x equals 2, which is equal to 2 times 2 to the power 3, which is 16, minus 2 to the power 4, which is 16, plus 2 times 2 to the power 2, which is 8, which is equal, then minus 0, minus 0, minus 0, and this is equal to 8. So that is the final answer. Okay? So you know now how to do double integrals in non-rectangular regions. Thank you very much. See you in the next video.